Module 6, Telecommunication and Networks. In here, you will be able to identify several telecommunications hardware devices and discuss their functions, and describe the benefits associated with the use of a network. Telecommunications is an electronic transmission of signals for communication. Telecommunication is creating profound changes in business because it lessens the barriers of time and distance. It is changing not only the way businesses operate, but the nature of commerce itself. As networks are connected with one another and transmit information more freely, a competitive marketplace demands excellent quality and service from all organizations. Telecommunications medium, on the other hand, is any material substance that carries an electronic signal to support communications between a sending and receiving device. An example of this medium is an optical fiber. This figure shows a general model of telecommunication, including its elements. The model starts with a sending unit, such as a person, a computer system, a terminal, or another device that originates the message. The sending units transmits a signal to a modem that can perform many tasks, which can include converting the signal into a different form or from one type to another. The modem then sends the signal through a medium. Another modem is another modem connected to the receiving device receives the signal, and then this process can be reversed. And the receiving unit can send another message to the original sending unit. An important characteristic of telecommunication is the speed at which information is being transmitted, which is measured in bits per second or BPS. Common speeds are in the range of thousands of bits per second or kbps to millions of bits per second or mbps, and even billions of bits per second or gbps. Telecommunications professionals consider the capacity of communication path or channel when they recommend transmission media for a business. Channel bandwidth refers to the rate at which data is exchanged, usually measured in bits per second. The broader the bandwidth, the more information can be exchanged at one time. This applies to broadband communication. Broadband communication is a relative term but generally means a telecommunication system that can exchange data very quickly. For example, for a wireless network, broadband lets you send data at a rate greater than 1.5 Mbps. Today's organization need more bandwidth for increased transmission speed to carry out their daily function. In designing a telecommunication systems, the transmission media selected depends on the amount of information to be exchanged, the speed at which data must be exchanged, and the level of concern for data privacy, whether the user are stationary or mobile, and many other business requirements. Communications media can be divided into two broad categories: the guided transmission media and also the wireless. In guided transmission media, this is in which communication signals are guided along with a solid medium. Wireless, this is in which communication signal is broadcast over airwaves as a form of electromagnetic radiation. This table shows the differences between the different guided media. So we have different twisted pair, coaxial cable, and also the fiber optic cable, their description, advantages, and also their disadvantages. On the other hand, this figure shows the actual picture of the guided media types for the twisted pair wire, coaxial cable, and also the fiber optic cable. Wireless communications coupled with the internet are revolutionizing how and where we gather and share information, collaborate in teams, listen to music, or watch video, and stay in touch with our families and coworkers while we are on the road. With wireless capability, a coffee shop can become our living room. Wireless telecommunication involves the broadcast of communications in one of three frequencies ranges, including microwave, radio, and also infrared frequency range, as shown in this figure. Also, we have their description, advantages, and their disadvantages. We have different types of short-range wireless options. We have the near-field communication or NFC, Bluetooth, and also ultra-wideband or UWB. In NFC or near-field communication, these are short-range wireless connectivity technology designed for cell phones and credit cards. With NFC, consumers can swipe their credit cards or even cell phones within a few inches of NFC point of sale terminals to pay for their purchases. Bluetooth is a wireless communication specification that describes how cell phones, computers, personal digital assistants can be interconnected. For example, the Apple Watch enables you to make a connection between your watch and phone. You can control the phone's music player from the watch and watch the timekeeping functions from uh, your phone. In the ultra-wideband or UWB, this is a short-range communications that employs extremely short electromagnetic pulses lasting just to 50 to 1000 picoseconds that are transmitted across a broad range of radio frequencies and of several gigahertz. We also have different mid-range wireless options. This includes Wi-Fi, wireless access points, and also Wi-Fi access points. Wi-Fi is a wireless telecommunication technology brand owned by the Wi-Fi Alliance. Wireless access point consists of a transmitter with an antenna which receives the signal and then decodes it. The Wi-Fi access point this have a medium range about 300 feet outdoors and 100 feet within dry-walled building. This is an example of a Wi-Fi network. In a Wi-Fi network, the user's computer or smartphone or even a cell phone has a wireless adapter that translates data into radio signal and then transmit it using an antenna. We also have different wide area wireless network types. We have microwave transmission, 4G wireless communication, and 5G wireless communication. In microwave transmission, this is a high frequency ranging from 300 megahertz to 300 gigahertz. This is a signal sent through the air. Microwave signals can carry thousands of channels at the same time because they are the line-of-sight transmission devices. Microwave dishes are frequently placed in relatively high positions or high locations such as mountains, towers, and tall buildings. 4G wireless communications will provide increased data transmission rates in the 20 to 40 Mbps range. Wireless communication has evolved through 4 generations of technology and services, and it is expected to deliver more advanced version of enhanced multimedia, smooth streaming video, universal access, portability across all types of devices, and eventually worldwide roaming. 5G is a wireless communication. 5G is the 5th generation of mobile network. It is a global wireless standard after 1G, 2G, 3G, and including 4G network. 5G enables a new kind of network that is designed to connect virtually everyone and everything together, including machines, objects, and also devices. It is designed to increase speed, reduce latency, and improve flexibility of your wireless services. This is an example of a satellite transmission. A communication satellite also operates in the microwave frequency range, as shown in this figure. The satellite receives the signal from the Earth station and amplifies the relatively weak signal and then rebroadcasts it at a different frequency. The advantage of satellite communications is that satellite can receive and broadcast over large geographic regions. Computer network consists of communications media devices and software needed to connect two or more computer systems or devices. This can transmit and receive information to improve organizational effectiveness and efficiency. The computers and devices on this network are also called network nodes. After they are connected, the nodes can share data, information, work processes, and allow employees to collaborate on projects. We have different types of network topology, but network topology is, by the way, the shape or structure of a network, which indicates how the communication links and hardware devices of the networks are being arranged. The three most common network topologies in use today are the star network, bus network, and also the mesh network. In the star network, devices are connected to one another through a single central device called hub node. Many home networks employ star topology. A failure in any link of the star network will isolate only the device that is connected to that link. However, should the hub fail, all devices on the entire network are or will be unable to communicate. In a bus network, all network devices are connected through a common backbone that serves as a shared communications medium. To communicate with one another or with any other device on the network, a device sends a broadcast message onto the communications medium. All devices on the network can see the message, but only the intended recipient actually accepts and processes the message. Mesh network uses multiple access points to link series of devices that speak to each other to form a network connection across a large area. Communications are routed among network nodes by allowing for continuous connections and bypassing block paths by hopping from node to node until a connection can be established. Mesh networks are very robust. If one fails, all the other nodes can still communicate with each other or directly or through one or more intermediate nodes. Depending on the physical distance between nodes on a computer network, the communications and services it provides, networks can be classified as personal area network, local area network, metropolitan area network, and wide area network. Personal area networks support interconnection of information technology within the range of about 33 feet. Local area network connects a computer systems and devices within a small area, example, an office or a home. Metropolitan area networks connects users and their devices in a geographical area that spans a campus or city, while wide area networks connects a large geographic region such as different countries. Here are some basic processing alternatives of a network. We have centralized processing, decentralized processing, distributed processing. In centralized processing, all processing occurs in a single location or facility. This approach offers the highest degree of control because a single centrally managed computer performs all the data processing. The Ticket Master Reservation Service is an example of a centralized system. One central computer with a database stores information about all events and records the purchases of seats. Ticket clerks at a various ticket selling location can enter order data and print the results, or customers can place orders directly over the internet. In the centralized processing devices are placed at various remote locations. Each processing device is isolated and does not communicate with any other processing device. The centralized systems are suitable for companies that have dependent operating units such as 7-Eleven, where each of its store in the Philippines manage and in other countries manage to meet the local retail conditions. While in distributed processing devices are placed at remote locations but are connected to each other via a network. One benefit of distributed processing is that managers can allocate data to the locations that can process it most effectively. Client-server system includes client-server architecture, which is a multiple computer platforms dedicated to a special function. These platforms are called servers. Each server is accessible by all computers on the network. Servers can be computers of all sizes. They store both application programs and data files and are equipped with the operating system software to manage the activities of the network. The server distributes program and data to other computers, or known as a client, on the network as they request them. Clients are any computers that sends messages requesting services from the servers on the network. While database server is an example of a server that sends only the data that satisfies a specific query, not the entire files. For example, selecting only specific values or inserting only specific values. Networks requires various telecommunications hardware devices to operate, including modems, multiplexer, front-end processor, private branch exchanges, switches, bridges, routers, and gateways as shown in this table. This will show you how these devices or how this telecommunications hardware works. There are also different types of telecommunication software. We have the Network Operating System or the NOS, the Network Management Software, and also the Software Defined Networking or the SDN. The Network Operating System or the NOS is a system software that controls the computer systems and devices on a network and allows them to communicate with each other. The NOS performs similar function for the network as operating system software does for a computer, such as memory and task management and coordination of hardware. When network equipment such as printers, plotters, and also including disk drives is required, the NOS makes sure that these resources are being used correctly. Whereas network management software is a software that enables a manager on a network desktop to monitor the use of individual computers and shared hardware, such as printers, scan for viruses, and ensure compliance with software licenses. Network management software also simplifies the process of updating files and programs on computer on the network. A manager can make changes through a communication server instead of having to visit each individual computer. In today's current network environment, each network device must be configured individually, usually via manual keyboard input. for a network of any size, this become a labor-intensive and error-prone effort, making it difficult to change the network so it can meet the needs of the organization. This is where software-defined network, or SDN, is emerging. This is an approach to networking that allows network administrators to manage a network via a controller that does not require a physical access to all the network devices. This approach automates tasks such as configuration, policy, management, and enables the network quality to dynamically respond to applications. All these factors are considered when creating an information system, since it is possible that we are creating an information system for a large organization connected via a network and also different telecommunications devices. So that's it, and thank you.